Hi guys, this is going to be question number 2 on collision for response homework paper. Here's a picture of the question. You have 0.2 kilogram of a clay, and then you have another object suspended from 3 meters length string, and it's also 2.3 kilogram. And as you see, this clay is launched with 12 meters per second at an angle of 30 degrees. And in part A, what they ask for is the distance that it's going to go on the horizontal axis. And this point is known as its highest location. So, to be able to start this, of course, remember when we have a vector with an angle, you always find the components of it, because vector itself with an angle is not going to help you, because we're always going to work on the x and y axis. So to be able to figure this out, you put this vector on the x and y coordinate system, and then this angle is 30 degrees, and then your x-axis is going to go from tip to the x-axis at a 90-degree angle, and this length from origin to the point where it intersected will be known as Vx component, so that's going to be Vx. And the way that we find that Vx is hypotenuse, which is 12, times, since this is the adjacent side of that angle, for adjacent we use cosine, so it's going to be cosine 30 times 12. And on the other side, its y component is going to be, again, from tip to the y-axis, and then it's going to go from origin to that point. It's also a vector, and this is going to be my Vy and my Vy. Since this side is the opposite side, and we use sine for the opposite, so it's going to be sine 30 times 12. So if you would like to calculate those, Vx is going to be cosine 30. So if you put that in your calculator, you're going to see that it's 0.87 times 12, and once you multiply this with 12, then you find your Vx as 10.4 meters per second. So that's your Vx value. So on part A, they are asking for something else, but once you have a vector, you always start with finding the components of it, because you're going to need that for the rest of the question. And over here, your Vy is going to be equal to sine 30, which is 0.5, times 12, which is 6 meters per second. So if you just put that in your calculator, you will see that it's 6 meters per second. So now, let's come to the point where it's asking for its distance. So like I said, momentum questions are not going to be single questions or questions just about momentum. They're going to be related to some other concepts as well. So over here, we're going to be combining it with kinematics, projectile motion, and we will also have some conservation of energy over here. So we know that this is the highest point, and once we are talking about projectile motion, we should remember to talk about all of the variables on the x and the y-axis. So on the x-axis, we know that my acceleration is 0, because there is nothing to move this guy to the side except the first initial push. After that initial push, there is no force acting on the object on the horizontal axis, so my acceleration is 0. And I also know that my Vx is constant and it's not changing. And on the y-axis, I also know that for this situation, at the highest point, my V final, alright, so I also know that this Vx for this question is 10.4 meters per second. And I know that this is the speed at all points on the x-axis, so it's always going to have that same velocity. On the y-axis, my initial speed is 6 meters per second, And then my final speed, when it goes up and up, it's going to slow down, and at the highest point, it's going to reach to the final velocity of 0 meters per second. So I know that at this final point, it's going to have a 0 speed. And I also know that my acceleration for that projectile motion system on the y-axis, gravity is always pulling it down, and it's negative 10 meters per second squared. And what are they asking for? They're asking for d, and d is my displacement on the x-axis, but my variables on the x-axis is not enough for me to figure out d, so I need to go ahead and get some help from my y-axis, because I have 3 values over here. That means I can find the other, or any other unknown. So that means, since we are going to have the connection in between x and y axis by time, so if I can find time over here, then I will just multiply my speed with that time, and that is going to give me the distance that is going to travel on the x-axis. So if you check your kinematics equation, for kinematics equation, then we are going to have this equation, v final equals v initial plus a t. And my v final is 0, my v initial is 6, plus negative 10 times t. So that 6 goes to the other side, it's negative 6, you have negative 10 over here, divide both sides by negative 10, then once you do the math over here, you're going to have negative 0.6 seconds. Then how am I going to use this 0.6 second? So that means it's in the air for 6 seconds, so it is going to travel with 10.4 meters per second for 0.6 seconds. And during that time, to be able to find a distance, d, you have to go with vx times time, and it will be basically 10.4 times 0.6. And once you do this, you will find that your distance is equal to 6.2 meters. Just meters. So again, that's about projectile motion. So you need to know what's happening on the y, what's happening on the x. Then you will be able to find the distance. Then in the next part, what they ask for is speed of the block immediately after the collision. So in part B, now we are going to figure out our velocity right after the collision. So at this part, we are going to basically talk about conservation of momentum. So this tiny clay hits with that suspending mass. So this is 2.3 kilograms, and then this is 0.2 kilograms. And we know that this guy is standing, so we know this guy's velocity initially. And then what else we know? You see, this is the speed of this clay on the horizontal, and my velocity on the horizontal is the same at all times. And since this is the highest point, at my highest point, my speed, like on the y-axis, is 0. So that means there is my speed for this clay to hit that block at rest is going to be this Vx. Then M1V1 initial plus M2V2 initial must be equal to, since they are hitting and sticking together, we are going to have a common velocity for both of them, and then that is going to be basically conservation of momentum equation for us. So then 0.2 times, this is the speed mass of my clay, and speed of this guy is 10.4 plus 0 momentum for the object that is suspending because it's not moving, plus and that's equals to 0.2 plus 0.3 times V final. So once we do the calculation over here, then we will find 0.2 times 10^4 is equal to 2.08, and that is equal to 2.5 times V final. Divide both sides by 2.5, and then you will find V final as 0.83 meters per second. So that's part B. In part C, they're asking for the angle theta. Alright, so that is going to be done over conservation of energy, because what's going to happen, if you remember in work energy questions, we were talking about releasing an object at a certain location and then finding velocity at the lowest position. So this time we're going to go backwards. So we have an object that is 3 meters below the ceiling, and then this guy is going to go some distance up because of that clay. So we will try to figure out basically this rise, how much it went up. So this height is going to be needed, because to be able to find this angle theta, I know that this is 3 meters because it's the same strength. So I know that this length, so to be able to find this theta, I am going to need this length. Because if I know this length, then I can use cosine function, because cosine is this length divided by hypotenuse. But to be able to figure this length out, I'm going to need that small tiny difference. So let's figure out how we find that height. So again, conservation of energy. So this guy is going to have some energy, and since this is the moment that it starts moving with 0.83 meters per second, so this is going to be, I'm going to set this guy as a 0 meter level. So conservation of energy states that kinetic energy initial plus potential energy initial must be equal to kinetic energy final plus potential energy final. So if I state my lowest point as 0 meter, then initially I'm not going to have any potential energy, because remember, gravitation potential energy is about height. So if you have no height, then you have no gravitation potential energy. So I'm not going to have any velocity, I'm not going to have any height, so my potential energy initially is 0. And once you think about this point, this is the point that it gets like the highest that it can go. So that means at this highest point, my velocity will be 0. So that means at the end, at this final location, I am not going to have any velocity, and that means I'm not going to have any kinetic energy. So then that is going to give us another simpler equation. Initial kinetic energy must be equal to final gravitational potential energy. And if you remember the equations for both of those, 1/2 mv squared equals mgh. So now we can get rid of the m's because they're not going to make any difference. They're on both sides, so they cancel each other out. So my velocity, my initial velocity is this guy. So 0.83 squared divided by 2 must be equal to 10 times height. So if you do the math over here, take the square of this guy, divide it by 2, divide both sides by height, divide both sides by 10, then you will find your height as 0.035 meters. So now, what do we have? we have this distance, this tiny distance as 0.035. Then the question was asking about the angle theta. So if you think about it, you subtract this tiny distance from this 3 meters, and then you are going to have this triangle right here. If you look at it, it's going to be so tiny actually, this distance, but we just exaggerate it. So 3 meters. And then this is this length right here, 3 meters minus this 0.035. And once you subtract this distance, what are you going to find? You will find it's 2965 meters. Alright, so now to be able to find the angle theta, remember cosine of this angle. Cosine theta will give me what? Adjacent divided by hypotenuse. So cosine of this angle, cosine theta is equal to adjacent divided by hypotenuse, so 2.965 divided by 3. And if you would like to find the theta right here, so you're going to need theta as arc cosine of this final number, so 2.965 divided by 3. And if you put that to your calculator, then you will find theta as 8.8 degrees, or 8.7, something like that. In part D, they are asking for if you had a heavier object, the clay, then how would this angle get affected from that? So thinking about it, your velocity, this initial velocity, is not depending on the mass. So that means you would have the same velocity regardless of the mass. So if you have more mass, you are going to have more initial momentum. So if you had more mass, you would have more initial momentum. And if you have more initial momentum, then your final velocity would be greater, which makes V final greater. And if you hit with a greater velocity, or if you have greater final velocity over here, that means this is going to have more initial kinetic energy. That gives object greater initial kinetic energy. And if you have more kinetic energy, that means you need to have more potential energy. And that means you need to have a greater height, which causes you to have greater potential energy, U final. So that height, so if that height is more, that means your angle theta